Welcome everyone to the topic of quadratic graphs. Before we learn how to draw a quadratic graph, it is important to learn what a quadratic equation is. Basically, a quadratic equation is an equation of the second degree, which means that at least one of the terms is squared. The general form of a quadratic equation is given by ax squared plus bx plus c. It is important to note that the value of a, which is the coefficient of the squared term, cannot be equal to 0. If the value of a is positive, the curve will have a minimum point, and if the value of a is negative, the curve will have a maximum point. To construct a quadratic graph, three things are required. The first is the x-intercepts, and these are the points where a graph cuts the x-axis. So these are the points where our graph is cutting the x-axis, and it can be seen that the value of y is equals to 0. The second is the y-intercept, and it is the point where the graph cuts the y-axis and the value of x will be equal to 0. The last is the turning point. Basically, the turning point is a point where our graph changes its nature. What it means is that up till a certain point, a graph is either increasing or decreasing, and after that it changes its nature. So let's look at this graph. Up till this point, the graph was a decreasing function. After this point, the graph started to increase, and it is basically an increasing function. So we call this point as the turning point. Now, to find the turning point, what we do is we convert a general form to the full squared form, which is represented by a into x minus h whole squared plus k, where h comma k are the coordinates of the turning points. To convert a general form to the full squared form, the first step is we expand the full square form and we get this result: ax squared minus 2axh plus ah squared plus k. In the second step, we compare our general form with the expanded form, full square form, to find the values of h and k. Let's take an example. We have to find the turning points of the equation y is equals to x squared minus x minus 6. We'll compare it with the expanded form of the full square form, which is ax squared minus 2axh plus ah squared plus k. The coefficient of x squared on the right hand side is a, and on the left hand side is 1. So we can deduce that the value of a is equals to 1. The coefficient of x on the left hand side is given by minus 1, and on the right hand side it's given by minus 2ah. Given that the value of a is 1, we can find that the value of h is 1 upon 2. The constant term on the left hand side is minus 6, and on the right hand side it is ah squared plus k. Substituting the values of a and h, we can find the value of k. Taking 1 upon 2 whole square on the other side, we get minus 6 minus 1 upon 4, which will result in the final answer minus 25 over 4. So the turning points are 1 over 2 and minus 25 over 4. Now, to find the x-intercepts, we'll substitute the value of y equals to 0. Solving the equation, this becomes x squared minus 3x plus 2x minus 6. Taking x common, we get x bracket x plus 3, and when we take 2 common, this becomes 2 bracket x minus 3. So the two values of x that we get when we solve this equation are x is equals to minus 2 and x is equals to positive 3. These are the x-intercepts. The y-intercept is obtained by substituting the value x equals to 0. When we substitute x equals to 0, we get y equals to minus 6. Using these coordinates, we will plot the graph. The x-intercepts were minus 2 and 3, minus 2 and positive 3. The y-intercept was minus 6, 2, 3, 4. And the turning points were half and minus 25 upon 4. Which means that it is 0.5 and minus 6.25. Once we have plotted all the points, we have to just join all the points to obtain our quadratic graph. Let's just correct it.